Good morning, April 27th. Real quick, I want to knock out a few data storytelling um, projects with the U.S. States project for those of you that have turned in a PowerPoint um, and pretty much everybody that turned in something is on the right track. I saw a couple of things where you might need help, maybe with a research question or whatever, but it's showing you're getting that part. If you haven't turned in anything, it makes me worry a little bit unless you've contacted me directly, like Thomas and I are looking at his motorcycle helmet wearing data. So anyway, if we could go in, I guess, alphabetical order. It's hard for me to. So Aaron is still catching up. Is Aaron, are you in here this morning?
Yep, I'm here.
Good morning. All right. But Andra turned in a good presentation. Andra, would you don't have to show your raw data, but can you bring up your PowerPoint and walk us through your project? Like
Sure.
3-4 minutes, and we'll.
Um,
Do I need to make doggone it? Zoom. Let's see. What is the? Do I have to make you the host? Can I not just say enable presentation, allow participants to, it doesn't let me let everybody present like I know Blackboard Ultra would let me do that. Does anybody know a Zoom setting for that, or do I need to transfer the host from person to person?
we can Google it real quick.
In the meantime, yeah, I'll do that. And in the meantime, yeah, there's nothing in there other than making you host. Now, I wonder if we're co-hosts. Nope, you are the host. So go, have at it, Andra, and I'll do a real quick Google while you're sharing that.
So you said just look at the presentation?
Yeah, just the PowerPoint's got everything we need.
Okay. So I completely changed what I first started with, but I went with something a little bit more simple. And I thought about, how many times have we heard that a lot of high crime areas usually correlate with people who are usually lower income. And so I got the average annual household income for each state and the crime rates of each state to see if there's any correlation. And there's really, according to that anyway, there really wasn't much of a correlation. And so I just thought that was kind of interesting. So I'm either missing some data points or there really isn't as much correlation as we think. And so, yeah, if you look at this was the R value that I got. So very, very low. Most of it just looks like scattered data. But, there is still a little bit of a correlation that the higher income household states overall usually have a lower crime rate, and then the opposite for higher crime rate and lower income. So there is a little bit, but there really wasn't as much as I thought there would be.
Yeah, go to your data analysis slide again. Look at that one outlier way up high at the top of the screen. Who is that? Yeah, we don't know. You'd have to go. Yeah, you'd have to go back. That's a crazy looking outlier, though, isn't it?
But I want to say it was something like Maryland.
Yeah. High crime and high income.
Right.
There you go.
But, yeah. So same thing. That was it.
All right. That's all I'm looking for, guys. But that shows that, Andra had to, go find some data, stick it in an Excel, clean it up, get it to where it was chartable and uh, analyzable by um, the statistics. So yeah, did you make me host again, or Andra, can you
Um,
make me host?
can you walk me through how to do that?
How did I do that? Yeah, when you hover the mouse over your name in participants. So click on the participants thing at the bottom of the screen,
Oh, let's see. Okay.
and you should get a panel on the right-hand side that shows all 11 of us.
Mm-hmm.
And if you hover over your name, you should see a more blue
Yeah.
more button. Click on that, and then one of those options, I believe, is
Mm.
no, I'm sorry, hover over
Oh,
my name. Hover over my name.
okay. I was gonna say my only option is rename.
Fool me once, shame on my name. No, okay.
Okay,
Hover
make
over
host.
my name and say make host.
Okay,
Poof.
that
All
should have
right.
done it.
Now, the way you do this for everyone's benefit is when you are the host, and you hover your mouse over the share screen button at the bottom, there will be an extra little green up up arrow. Um, Click on advanced sharing options, and then who can share all participants, who can start sharing when someone else is sharing all participants. So yeah, it's mayhem. We can all share now. We should all be able to share now without me doing anything else. We'll test that theory with the next victim. Well done, Andra. Any questions for Andra?
I do have a question.
Okay, Laura.
Yeah.
So are those crime figures the total crimes reported, or is it like a crime per capita?
So yeah, I had to do the math on that because the graph only showed like a number per 100,000 population. So I did do that multiplication. So it is the total. But the thing is that it is only reported crimes. So like how much of that isn't reported, But yeah, do you want to look at the Excel sheet?
Yeah, if you have that, we can look.
Don, do you mind if I take
I don't
over
mind.
for
No,
another second?
are you kidding? You guys getting in there and mixing it up? That's great.
Okay, so let's try this screen share. Are you guys seeing that?
Mhm.
Okay, so let's hide all these. So these are the numbers that I found in a graph, and they were per 100,000 of the population. And so what I did was, so I divided the population number by 10,000 and then multiplied it by the number on the graph, I think is what I did. Yeah. And so that gave me the total number. And then this is the number I used in the graph. And then I realized that Excel doesn't like it if you use this column with the formulas in it. And so I copied just the number over into a different column to use in the scatter plot because it wasn't cooperating. So, yeah.
Yeah, that brings up a good point. If you do per capita, it kind of puts things in context, apples to apples, and there's a lot of other things like that where two variables interact to form a ratio that is really more informative than using the raw count of a particular thing, like you would think more people, more crimes, all things being equal, of course, there would be a correlation between directly between population and crime, but not necessarily. But crime per capita is perhaps a little bit more informative.
Right.
All right, cool.
I'd imagine education might have something to do with this too.
But then there's
Probably more than income.
population density, so that's still a ratio.
That's true.
People per square mile. I would think that more densely populated areas would have more, chance of conflict and that was my parking spot.
Right.
Fights and
So
whatnot.
they are definitely slightly correlated, but there's just more to it than these two items.
There you go. And that's the life of an analyst, always looking for for more of what might tell the tale. All right. Thank you, Andra. Moving on to any other questions? Andra, do you have any final comments?
No.
Cool. Once, twice, three. Cool. And guys, Brittany from Waco decided not to continue with the course. She was really concerned before we got started about the applicability and her ability to balance the work and the training. So the rest of the four Waco folks are still with us, but Brittany's going to back out. So she could just be jealous of you guys and these new horizons you're learning. Okay, let me get past Brittany. I'll drop her out of the course there. So Chase, you got something to show us?
Yeah, so my research question was similar to Andra's, but much more basic. I was just trying to, get used to all this new information. But my research question was, does state population have an impact on violent crime? Of course, the null hypothesis would be that there is a strong correlation. Alternate hypothesis that there is no correlation between population and crime rate. So for my data source, found the statistics on the FBI's .gov website. They had both the population and the crime data. They also had crime data for property crime, but I just took the violent crime numbers. There's various types of crime, I guess you could say they're different, but I took the total, so that there may be some outliers in my results, but to do my chart was just a scatter plot to show, obviously, as the population increases, the rate of crime does increase. It's almost the R value is almost a solid 1.98. So there's a strong positive correlation there. Recommendation: accept the null hypothesis, reject the alternate hypothesis, and that's it.
Okay. Fair enough. Yeah, just like you said, you would think more people, more crime, all things being equal. Not looking at any other variable, you might think that that would correlate.
Sure.
So nope. So there you go. And some things will be like that. Some things will be intuitive, and then you'll turn around and it, like if you did world population, I would bet you if you looked at every country in the world and you looked at their population and their murder rate, you might see a different result. I think violent crime might be more of a phenomenon in certain parts of the world than others, just intuitively.
Sure.
So hard to say. All right.
Disappointed I couldn't share I got kind of carried away with my PowerPoint. I had Peter Griffin and the chicken fighting in one of them from Family Guy, but someone may have got a kick out of that. Maybe it's me, but
Well,
anyway.
don't you didn't share your PowerPoint, but you guys should feel free coming up here. Let's see who else can we put in the spotlight. Okay, Chaz, You want to share your PowerPoint? Chaz, is that a yes? Am I muted? Nope. Chaz, can you hear me? Chastity, are you okay? There you are.
Your headphones must not be working. We
Yeah,
can't
you're
hear
not
you.
muted, but we can't hear you talk. 1, 2, 3, 1, 2, 3. Nope. Nope. Can't hear a thing. Go to you want us to go to somebody else? Is that what that was? Sometimes you can pick your microphone, Chaz, in the lower left-hand corner, the mute button. If you hover over the mute button, there's a little up arrow, and if you click on that, you can pick your microphone. Sometimes that might be the issue, but we'll move on while you get that figured out. If you want to do an audio test in the middle of the next person's presentation, you should feel free, because we're all friends here.
Can you guys hear me now?
Yeah, there she is. Okay. Yes.
Okay. Refresh it or something. I don't know why.
Huh.
But
Go ahead.
okay.
Share your
You do-
PPT.
Okay, so how do I take control to do a presentation?
You shouldn't have to
To
take
hover
control.
over?
Just down at the bottom, there's a green share screen
Oh,
button.
share screen. Gotcha. All right, can you see my screen?
Sure can.
Yeah, awesome. Okay, let's start at the top here. Okay, so for my analysis and my research question was just curiosity mostly, if there was any kind of correspondence or correlation between obesity or overweight statistics with an individual's education level. So my null hypothesis was that they're not correlated, and of course the alternate was that there was a coordination or there wasn't a correlation, so a negative or a positive. And I got everything from the CDC stats from 2011 to 2019. I just processed all of the data from those points and found that really there was a very, very low correlation coefficient. So not really any relationship between those two items. And you can see across the bottom, it tells you the different obesity versus overweight, the BMIs, across college graduates down to post high school. Actually, I should have sorted that different now that I'm looking at it for order anyways. So yeah, ended up with very weak negative correlation. And so the hypothesis was correct that there is no correlation between the two.
All righty. I'm trying to look at your
Data.
raw data, and it's not cooperating. And this, I'm in the preview mode. I haven't downloaded it. Ah, there we go. I am going to. Okay, yeah, it's in a pivot table. I'm going to take a look at this because I think, Chaz, there's a way. If I were a statistician, I think there's a different way that we could look at this. The score, because what you're comparing are two categorical variables to say that and your real question is, does education level predict BMI category? Does educational category predict BMI category, or vice versa? Because you might shun potentially. You might shun the educational experience because you have body image issues, or you might gravitate to that because of it's a fairly welcoming environment. I've worked in academia. It's a fairly inclusive environment. And then again, there may be nothing to do with it. May have nothing to do with nothing. So if you don't mind, I'm gonna send this to Whitney to see how she might look at this, being the pro that she is, because I just kind of have an idea of what I would look at. Again, I'm not a statistician, but I think she might be able to shed some light, and she knows how to jump on Zoom and record like a 3 or 5 minute. Here's how you do it. So that may be what you would look at. Pearson's R. But I don't know for sure that it is. With categorical variables, those throw me off a little bit. I know with the continuous linear, numeric stuff, that's fairly straightforward. So cool.
Stats are completely new to me, so this is not at all in my wheelhouse. So I would love to hear her feedback.
Yeah, me too. Cool.
Great.
Good example though. Very illustrative example of comparing categorical variables to see if one can predict the other. And you just because of the way the data is blocked out there, you got to use slightly different approaches. So all right, cool. We are up to do another couple of these things. Damon, are you in? Oh, you're on board, aren't you? Yes.
Yeah, I'm here.
Why don't you show us your PowerPoint?
Give me 1 second.
Show us what you got. Is that all you got? I'll take your best shot. Is that all you got?
All right. Can you guys see that?
Take your best shot. Yes, we can see it.
Okay. Good deal. Mine is a little, I guess, out of order from how you did yours. But the research question that I had was, hold on, trying to minimize. There we go. How closely do Medicaid/Medicare total costs correlate with the condition's prevalence in all states? So I found this website that was all about mapping healthcare disparities and whatnot. So they had all this information statewide, just about the prevalence for certain conditions like diabetes and COPD, depression and asthma. And I actually kind of did two, but based my null hypothesis off of the first one. But because the data was kind of a lot, it was kind of hard to do a scatter plot with what I had. So I guess the second question is what my graphs are kind of based off of. I hope that's okay.
Sure.
So null hypothesis, total costs have no correlation with prevalence. And the alternative has a positive correlation or a negative correlation. So kind of going to the findings. So you guys can see down here, and I think I did this right. I'm pretty sure these are R values. When I did the whole correlation thing in Excel, this is kind of what it spit out for me. And so diabetes prevalence, with diabetes average total cost per beneficiary, pretty weak correlation here, though negatively correlated. We can look over here at COPD prevalence and see that average total cost, also pretty weak correlation. Depression, I guess it's weak, but a little bit better than the others, as you can see. And with anxiety, we can see that that correlation. And I think when we did this, it kind of based these correlation values on all of the states, if that makes any sense. So after that, I kind of looked regionally at some different states to see what they were spending versus what they were like the prevalence. And I kind of put some of the findings over here on the side. The warm colors are the like physical conditions, physical chronic conditions, I guess you could say. So diabetes is orange, and COPD is that red shade. The line here, the lines are the prevalence, and histograms represent the total cost. So this is just a way that I could kind of see, I don't know, the gap between the two. And you can kind of see that, like say diabetes, like it receives the least amount of spending as all of these conditions, but it has the highest amount of prevalence. The same thing for, well, not the same thing, but you can see kind of COPD is the highest out of all of these for total cost. So like what's being spent within Medicare, Medicaid on this condition. And it has the lowest prevalence. So, you know, that's saying something. It's kind of a little bit of a flip-flop, like when it comes to the mental health stuff, depression's higher than anxiety is in prevalence, but you can still, anxiety, I guess, is getting more spent on it. And this is also the southern states, by the way. I'm not sure if I pointed that out. So after that, I tried to look at the northern states just to do some kind of comparison there, because it would have been a lot to do all 50 states in one map, as y'all can imagine. So let's see, diabetes still pretty high here. Still receiving the least amount of spending, as you can see by the histogram. COPD still the highest and whatnot. I tried to kind of eyeball this. So like 4 out of the 12 northern states have a depression prevalence that's greater than or roughly equal to 20%, compared to like 2 out of 12 southern states, and like 4 out of 12 northern states have a diabetes prevalence that's less than 25% compared to all of the southern states. And yeah, just try to generate some findings from that. The difficult part, the thing that kind of throws it off a little bit, the axis over here, because this only goes up to 35,000, the secondary y-axis was pretty much perfectly aligned. You can see the 30 goes along the 10 and whatnot with those lines, but over here, because it went up to 45,000, it kind of got a little skewed over here, so it's a little hard to tell. Like the 10 is kind of in the middle of, you know, it's not really on a line. So I kind of had to eyeball it a little bit. But
so Damon, the scale on the scale on the left is the bar chart or histogram scale,
so that's
and the scale on the right
cost.
is for the line graph.
Exactly. So that's for the prevalence over there.
Yeah.
It's called, when I went to like make the graph, at the very bottom where they have all the lists of the different charts you can choose, there's one called combo. And from there, you can just kind of choose all your variables and say you want it to be a line or you want it to be a histogram. And you can say, I want it to be on the secondary axis, or, you know, not check that box and it'll be on the first one. So everything that was prevalent, I just said I want it to be a line and I want it to be on the second axis. And the other things, the total costs, I left as a histogram and on the first axis. So, yeah, I think that's what I got. Like I said, not a lot of correlation between those two like we'd expect, but I it was kind of difficult because the site had two different things listed out. One was adjusted and one wasn't, and I tried to go to the PDF to look at the to kind of see what the difference was between the two, but it was a very long and technical thing, so I couldn't really digest it super well. So I kind of just went with one, but I have that source there, and yeah, I open any questions you guys might have.
Cool. I'll let y'all go first. Okay, well, I had one, Damon. This is this is impressive, and it's almost like two projects in one, because you could have just looked at the cost versus the prevalence of a disease, and kind of like what I put in your feedback comment in the classroom is this kind of analysis could be used to make public health policy decisions or spending decisions, like, COPD, few people have it, and those people with that condition are costing, the fund a disproportionate amount of money. So that would be a place to go and attack, from a cost standpoint and purely from a cost standpoint. Do you know why COPD is so expensive to treat? Is it the inhaler or the open bottles, or what?
I'm not entirely sure. It's one of those things that I'm constantly making maps for, like with my job. It's one of those chronic conditions that we're always concerned about. Diabetes is another one, but I think COPD, I don't remember what it actually stands for, but
I'm leading you. That's something you can answer. Why is COPD too expensive? So you would see, you may not even know. Your first research question is what chronic diseases are most prevalent, and then you look and bam, whoa, COPD, look at that, and then you look at the expense, and then you say, well, why? And then you go into the expense and you start to slice and dice down there, and you start to categorize on, if it's treatments, or it's prescriptions, or it's therapeutics, or whatever the case may be. You start to look at why it's expensive, and that data would start to feed management decisions, kind of thing. This is a great project, great example.
Awesome, thank you. Yeah, with this, I was thinking maybe that this gap kind of shows that, okay, they're not really spending a lot, say, on diabetes, but the prevalence is really high. So maybe there's just some maybe with more spending, maybe they can kind of bring down that prevalence. That was my first thought, but yeah, you're right with what you said too. But yeah, did someone else have a question? I feel like I heard something.
I had the same question. I was interested in the number of beneficiaries, like what the looks like in total spending.
I don't know the exact number for each of these states. I think all I can say off the top of my head is that it includes all of those on Medicare and Medicaid. I want to say, but exact numbers, I'm sorry, I don't have those.
30% of the people in New York have diabetes.
That is what this is suggesting. I'm not sure.
Times $15,000 for a third of the population of New York per year.
I'm thinking so. I could bring up the link to the data if you guys wanted to see it. But yeah, I think that's what that's saying here. So that's that histogram is saying how much they spent, and that the line graph showing that prevalence.
Dang, that's the technical term for a high statistical correlation. All right, good stuff, Damon. And I'm just asking, rhetorical follow-on questions, just like your management will, and you'll go, well, let me dig into that. I don't have those numbers right in front of me, but I'll get back to you.
Yeah, it offers some direction for sure. Well, I appreciate it. Thank you all.
So I vote.
I'm a hand.
Yep. Unshare. Let's see.
Mm-hmm.
It is 9:06. All right. I want to do a little bit of housekeeping. And let's see. I got attendance taken care of. Did Priyanka ever come in? Real quick.
Priyanka's out today.
Priyanka's out for the day? Okay. So I got Aaron, Andra, Brittany's out, got Chaz, Damon, Erica, I believe, is out. Yeah. I got Laura, got Lindsay, got Thomas, got Chase, got Gabe. Okay, cool. Put that away. I want to share that real quick. Okay, I'm going to share that tab. Everybody seeing the familiar classroom tab? All caught up with the session recordings. If there's something you want to rewatch, maybe like Whitney's question and answer session or Brian's inference session. Oh, I got to publish. Publish. Arg. Aaron's probably wondering. You wondering where that recording was for the 22nd?
No, I found it on your YouTube channel. I clicked on your profile and found it.
Cool. More hits on my YouTube channel. I'm trending. Okay, so I'm caught up with the recordings, and I wanted to, before we go on break, show you what we're covering, what I've uploaded, and what we're covering today. So some new things that I have uploaded are down here in the foundations module. Down here, Whitney, Dr. Worley, emailed me some stuff, some materials. It's worth a glance. I'm not going to go into statistical theory much anymore or try and allocate time to it, but she has a really good PowerPoint. It's like a quick tutorial, like a website or anything else, on inference, and then above that here on probability theory. Probability is really cool. Like if you're a blackjack player or a roulette player or whatever, you know what I mean. You always want to know what the odds are of something happening based on maybe something else. If we're halfway through the deck and I've seen these face cards and I double down, what are my chances? What are the odds? So probability theory is pretty interesting, and it makes for some interesting programming simulations too. I wrote a Monte Carlo simulation when I was in college to simulate card games based on hit me or not, or whatever, those sorts of things. So that was fun. So there's some stuff here from Dr. Worley, and then all the way down in advanced, I uploaded her advanced. I uploaded her intro to R PDF. She does again a tutorial sort of, and I've got a session recorded from her. I'll upload that link as well, from the last one last summer. But today, go to the module, and you can collapse these with this arrow. Not doing advanced, not doing visualization. I don't think we're going to get to it, but if we do, in Python, under your basic Python page, I want to get to notebook 3 and 4, so you can go ahead and download those. And if you've got time, you can check them out if we don't get to them. But otherwise, I want to go through input output basics, which is really just printing to the screen and getting input from a user. That's all we're going to jump on for that. And the other one is just if then else logic. So remind me, guys, I teach a couple of other classes, and I've gone into a little bit of this in that we haven't gone through if then else in this class, have we? In Python? notebook number 4? We have not. Thank you, Laura. I can see you shaking your head no. Everybody else is a plain box of emptiness. Just in case you haven't gotten, I like cameras to be on, but I'm not going to make you do anything that makes you uncomfortable. Okay, so go to your relational databases module here. You are going to want to download this PDF, RDBMS Design Fundamentals. That's what I'm going to cover after the break. And then you might as well go ahead and download these 4 files. I try and use that DAAT 16 March naming convention. That means I've looked at it, I've checked it, it's ready for class. Anything that doesn't have that in front of it is suspect. But this is also a link. We're gonna, when we go into design fundamentals, we'll quickly go over how to graphically depict a relational database, and you'll need these diagram symbols. So I'll go over that too. But you might as well go ahead and download these 4 2 PPTXs, a .sql file, which is actually a text file, but it's SQL code, and this PDF is a visual depiction of the database we'll be using today. So yeah, go ahead and download that stuff. If you have not already, download SQL Workbench 8. Before we go on break, anybody have any problems with downloading SQL Workbench? That's going to slow. Okay, everybody's got it. Okay, cool. So I'll walk you through the connection parameters probably in that third hour. All right.
I did have a question, Don.
Yeah, Chase, go ahead.
You said we did not have to download MySQL.
Correct. Not
I get, okay, because I did just the Workbench, and I guess that's why we're going to show us how to connect to the server.
Yeah.
Okay. Because for just the Workbench, it was like it can't find anything, or I got that weird message. So
yeah, it doesn't. It's just an application on your desktop waiting for you to connect it to a database.
Okay.
Now, if MySQL is in your future, you're probably going to want to download the desktop version.
Okay.
But depending on your work environment, you'll have like a test database or production databases that you'll be connecting to, and in Workbench you can have a tab to be connected to dozens of databases and be pulling stuff from all over the place. So yeah, I'll get you connected to our classroom database this morning, and we'll start doing some SQL this morning. But yeah, it couldn't hurt to go ahead and make sure it's installed, but probably don't need to bring it up. It executes pretty quick. But yeah, this RDBMS Design Fundamentals PDF, you're probably going to want to follow along with that. I mean, I'll screen share, but it's probably more readable on your own screen. But it's up to you guys. I will see you back here at 9:30 cell phone time.
If you're talking, we can't hear you.
I'm just kidding. I was waiting for somebody to. Hey, idiot, your headset's on your desk.
I just thought my audio was messing up again, so I was checking everything on my laptop.
No, I'm just cutting up like I did starting in kindergarten and never quit. I've always been the kid most likely to get kicked out of 8th grade Spanish for cutting up. I told you that story, right? Hi, Don Walker. I know you. All right. So I spent a little bit of the break walking around, as you all should, because health is much more important than knowledge. And petted my dog, and then I spent 5 minutes looking at your project, Chaz, and I'm gonna take a look at that because that's fascinating to me. You got those two categorical variables, I think, and especially, like they're ordinal categorical variables, which means that the order of the categories are kind of like a ranking from underweight to morbid obesity, and from less than high school up to I didn't see what the category was. Post.
To college degree.
Hey, Don.
College graduate. That's it. Yes, sir.
I've got an error on my workbench telling me that telling me I need to install Visual C++ redistribution package.
Well, did anybody else get that? Because it'll
I
tell
did.
you, it'll tell you a wrong version of this or that. But I'm trying to remember. I installed Workbench well over a year ago. I'm trying to remember if is there a link to click on to download the?
It gives me a list of download prerequisites. Well, actually, it doesn't. But there is a C++ connector piece out on the site. I don't necessarily know if that's the same thing.
I just downloaded mine during the break, and it didn't have that, but it did require admin permission, so I had to contact IT.
Yeah, that is true. If it's a work computer and you don't have admin privileges on your desktop. Yeah, that's. I tried to get ahead of that at the beginning of the class with these different downloads, because some folks, it's almost a showstopper to download open source software like that. Like I said, there's parts of this where we can use the Northwind database with access, but it'll get a little unruly. So we should really try and sort that out. Like I said, it won't be such a big deal today, Thomas, but if maybe you could do a ticket with your IT guys, and let them know that you need that installed, and they might be able to just come down to your computer and just figure it out and have it installed on your computer. Then again, if there's a disregard, I understand button, and you can get past it, it may be nothing, because I get an error that tells me incompatible versions of something or other when you go to connect to this. It's actually MariaDB, which is a type of MySQL database. So there's, and it's a warning. It doesn't mean anything. So I've clicked in the "Don't tell me this anymore" box. So it may just be a warning, Thomas. It may not be a fatal error. So we'll check that out in maybe this hour, maybe the next, if I stop yapping. So I wanted to go over relational database design. And I never paused recording. I apologize to those of you that watch the recording. You get 15 minutes of blank screen. Lots of the data that you see out there that you're dealing with in Excel is not relational. It's not designed using this relational database design principle, like you would want inside of a database. And as an analyst, you may very well pull data out of a relational database, and that data sheet is no longer relational designed data. So they call that these flat files we've been working with. They call them either a flat file or tabular data, where you've got a column and things can repeat in there, and it's not a way to store data. Excel loves it, and other programs know how to, like pivot tables. They know how to condense and summarize that data, but you wouldn't design a database to store data in that format for normal operations. So that's what we're going to go over on this hour. Is what is this relational? Why do we care? So let me go to my and find where I put it. There it is. Okay, this PDF I told you to pull up is a lecture I found online that keeps me from having to do it, and it's exactly what I would have developed. So I just use it, coming from University of Kansas. Let me share. There it is. Okay. So the reason you're learning this is that so you understand kind of how these databases are put together and how to read a diagram. It's called an entity relationship diagram. And how so you'll understand how this relational database is put together, and you'll be able to construct queries that will pull either answer your question, because SQL can definitely analyze data and answer a question, or you very often you'll use it to create a tabular data file that you will use in Excel or Python or Power BI or Domo or something else. Okay, so database design, here we go. This is kind of what we'll go over. What is a relational database, and then you hear the term keys a lot: foreign key, primary key. It's pretty simple. And then we'll go over this process called normalization, which is where that's where a database designer, not necessarily an analyst like you, but when the person that's actually putting the database together, or if you decide to make like a data warehouse for your own analysis purposes, you want to put it together normalized, which just means it's designed properly, and then pull data out of it once it's normalized and set up. And that that data can be coming from multiple sources. You design the database, and then you do the code to load the stuff in there, however, to meet the constraints of the database. And yeah, tables are related, and types of relationships, and we'll go into all of this here this hour. Okay. What is a relational database management system? A database is a collection of information. So that's a like a lowercase d, fairly generic term, right? A relational database management system is a piece of software that runs on a computer, either desktop or a gigantic multi-user scenario in the cloud, whatever, and then everything in between. But the database management system is a piece of software that you go through to access the data, whether it's using a third-party tool like Excel or Power BI, or you're logged into the database itself. The database management system really owns the data and decides where to put things out on disk, and it manages things like permissions, who can see what in the database, who's allowed to create things in the database, those sorts of things. But generally speaking, when we talk about a database, you'll hear the word schema, is a collection of data organized in tables, and tables look just like an Excel sheet, columns and rows. No more complicated than that. A table can also be called a relation. It can also be called an entity. It's a thing. You have a person table, and then in that person table you store information about each of the persons of interest. Yeah, and so you have columns and rows. A column is just like we've dealt with in Excel. It's the age or first name or whatever, those sorts of things. But when you're doing design, it's also an attribute of that entity. That person in design speak is an entity, and entities have attributes. Like a person has, hair color, date of birth, those sorts of things, and you set those up in a certain way. A set of attributes is a record. So a row in an Excel file, a row, a record. You'll also these databases use the term row as well. Records. Kind of more the generic term. So records are also returned as rows or tuples. We'll learn a little bit more about tuples in Python, but I don't ever work with that in databases. So yeah, you'll see, like when we're working with SQL, you'll see it 14 rows returned. That's the term they use. And then tables in a database are related to each other, hence the relational database, through a key field, which is a unique identifier for each row. So like in a person table, you would have some sort of unique ID, like employee ID. I made the mistake 30 years ago of letting a military organization use social security number as the no kidding database primary key, which is a horrible practice. That's the other. I'll probably say that 9 times. You never want to use anything meaningful, not even employee ID, as a primary key. The best practice is to let the RDBMS assign a unique key that means nothing other than it's a record identifier. You don't ever have to you use it in queries, but you never have to actually memorize it or anything like that. So that's what I would recommend as far as a primary key is the unique identifier in a table that identifies each of the rows uniquely. And yeah, allows you to find stuff. They generally will be indexed. Your primary key field is automatically indexed. So if you've got 1 million rows and you're searching based on that primary key field, it finds it very quickly. Okay. Primary key and foreign key. They are kind of the same thing, just used in different contexts. Primary key is, like I said, it's a unique identifier, and it can't be blank. And that's how you identify, Bill Smith from Joe Smith, is the primary key of that table. Every table should have a primary key field, just as good design. And like I say, I think they should be system generated. But concatenated keys are where you can take something like it's almost never good to do it this way, but you could take something like first name and last name, and you're only allowed to have one Bill Smith. It's rarely a good form, but you'll see that a concatenated key is taking 2 fields that together will ensure uniqueness. And then a foreign key is, and we'll get into this, but a foreign key is is a table's primary key used in another table that links back to the first table, and we'll get into that in the diagrams. It's a little easier to see what we're talking about. And yeah, it's got to match exactly. So, for example, if you had employees and you wanted to track their cars that they're allowed to park in the parking garage, they might have more than one car. So, but each car's got to be associated with just one employee. You can't, you don't allow the situation where maybe a husband and wife work and they both have 3 cars or whatever. So just in theory, the primary key for employee in the car table might repeat for as many cars as they own that are allowed to park in the parking garage, but they're all associated to one employee. So that key over there in the car table needs to be exactly the key that you're using to track an employee in that parent table. So that's primary key and foreign key. They're like I said, the diagrams will make it a little easier, and then we'll go through some practice as well. Normalization. It's just the process of designing data so that it's right. It's almost intuitive when you learn it, and then when you see somebody violating, there's 3 levels of normalization that we'll cover. First, second, and third level. There's 5, but we only do 3. And I think there's a 6th, Boyce Codd normal form, with the guy that wrote SQL. But anyway, there's first, second, and third normal form. And after you've been working with relational databases for a little while, you'll start to recognize that ain't right. That's not properly normalized. So once you learn it, like I say, it's almost intuitive in how you would lay out data. But there is a process to identify we are in first normal form, we are in second normal form. We're satisfied, we're in third normal form. And I'll give you some examples here. And again, in that big yellow block, third normal form is sufficient for most typical database applications. I don't know where it's not. So if you guys run into that, I'd love to hear about it. I think above third level form, you start having like similar databases, but like you got one for Europe and one for North America or whatever, and you have to have something to keep those 2 sets of data uniquely identified, kind of thing, but they're completely separate. Anyway, like I said, third normal form is good enough. First normal form, these are the rules for data to be in first normal form. And they make little sense until you start seeing examples. No repeating or duplicate fields. This would be like having an employee table with car 1, car 2, car 3, car 4. You wouldn't have because you're just going to have to go modify the database as soon as somebody has a 5th car, right? So no repeating or duplicate fields. And you also don't want to have like hair color 1, even hair color 2, but no repeating or duplicate fields. And you don't want to put, for some reason, like blue Chevrolet in a single field. You want each column to be one value. And then first normal form, each record is unique and identified by a primary key. So we'll see this first normal form in the next slide here, and why it's not. This is not in first normal form because you've got multiple things in your color column, and there's no unique identifier. There's really no way to uniquely identify any of these rows. So this might be something that you see in a spreadsheet that you can kind of do a little bit of what is the total cost of the t-shirts we have on in stock. I mean, if this were a spreadsheet, you might be able to get some answers out of it, but it's not good database design. So you would break that out. And now the primary key is a concatenated key where you only have one type of shirt in one color. And again, you're not going to, that's bad form. You're going to have like a product ID or something that's going to be the primary key. But this is just an example of how to fix something to get it into first normal form. So you have red t-shirts, blue t-shirts, red polos, yellow polos. There you go. And those two in yellow, those two fields form a concatenated primary key that uniquely identifies each row. There you go. Okay, second normal form, all non-key fields, so everything but the primary key, depend on all components of the primary key. And this is, again, why you hate concatenated keys. Every other column only depends on the primary key. And there's an example in the next field here. See here the tax rate for t-shirt and polo are the same, but it's the tax rate, and this is just an example. Tax rate is different for sweatshirts, but it's got nothing to do with color. Blue, here's two blue shirts with different tax rates. So they depend on the item, but not the color, but yet we have this concatenated key, which is, it's like I said, it's just goofy. So this gets you to second normal form, and it starts to show you an example of where you're going to want to break things out. So you would have, in this example, and I don't want to get too far ahead of us, you've got a, still got a concatenated key from before, the item and the color. But now you're starting to see it broken out into two tables. You've got a product table on the left there. We haven't named it. We're still just talking, generalities here. But now you've got a price and tax table for each item. So you can see now that we're starting to have a relationship. The t-shirt, regardless of its color, is gonna be $12. The sweatshirt, regardless of its color, is going to be $25. Now here's another issue. Notice the tax isn't calculated based on the price. It's not a percentage. It's a raw number. We'll get into a little bit more of that too. That's probably not the way you would want to store your tax table. You probably want to calculate your tax on the fly based on a table that had the tax, the rate, the tax percentage versus storing a calculated field like that. But anyway, this shows you now that we've broken that out, and that puts it in second normal form. And then good old third normal form. This is where everything's right. You know what I mean? All non-key field, it satisfies the other stuff, and no non-key field depends upon another. So you don't have maybe sex and hair color where we only have brunettes that are female or whatever. You don't, but it has nothing to do with the primary key. You don't want to have anything goofy like that. So we've got, again, an example. Yeah, here we go. Your tax is depending on this price. It's not dependent on the item over here. So you don't want to do it that way. And again, this is an example. I wouldn't do it quite this way. But it shows you how you don't want to calculate. You don't want to store the tax amount with the item. You want to store it with the price, because that's what it relates to. That's what it depends on. So now we're starting to see what looks a little bit more like third normal form. But again, once we've got further to go here. But that's third normal form, where you start to put things in their own table so that it follows those rules, those textbook rules, but you'll start to see it when you see these tables and start working with queries. I'm thinking particularly in your production databases. And I'd love for you guys to get with your workplace mentors and trainers and get with somebody who understands database design. It's not always the database administrator. Those guys are pretty good at making sure it stays backed up and looking at overall tuning and performance and disk space usage and security, permissions, those sorts of things, but they're not necessarily real good at database design, the actual structure of the and rules of the rule set of the tables inside the database. Sometimes they are, but not always. So if you wanted some examples, I would encourage you to get with somebody in IT and have them show you some of the production databases that you work with, so that you can see an example of primary keys and foreign keys and table structure. They can get really complicated in some environments. Okay. Here's another example. Yeah, assignment 1, assignment 2. Say this is a class, a college class, and you've got students over here. You would never want to modify your database structure, not the structure, to add an assignment. You always want, when you're adding things routinely, you want them to be rows in a table. You don't want a routine thing to change the structure of your database. I guess is the logic behind that. So yeah, assignment 1, assignment 2, and then you've got first and last name in there, which it's goofy, and there is no primary key. So yeah, that jumps off the page at you if you're a database designer. It's wrong. Another example. Oh yeah, here's where you would you'd have an assignment table that described the assignment. It might have the instructions. It might, most databases will let you store files in the database. So it might have, like a template, a writing page, a paper template for you to use, or a data file to use, or something like that. It may have other things about the assignment, what the grading scale for it, or the number of points for it. And then you've got a unique identifier for students, student ID, and then maybe you don't assign every assignment to every student, so you've got a joining table here that shows you what assignments have been assigned to what students, or what students have, what assignments do, those sorts of things. So that's how you start to model what we'll see here is when you have a many to many relationship. If you have many students and many assignments, you're going to need to figure out you're going to need something in between to track those too many relationships. You'll need something in the middle, and we've got a few examples of that. How am I doing, guys? Everybody doing okay?
I have a question.
Sure, Dan.
Is student ID there? Is that the primary key, and is assignment ID the foreign key, maybe?
Okay, the student ID. Great question, Damon. Thank you. The student ID is the primary key in this would normally, they're not showing the table name yet, because we're not really there yet, but call this the student table. And student ID is the primary key of the student table. And then we'll call this the assignment table. And assignment ID is the primary key of the assignment table. Assignment ID, we'll call this the student-assignment table. Assignment ID here is a foreign key. It's a foreign key because it's the primary key over here in the assignment table. Now, this is wrong. They've got student ID highlighted, but that student ID is not the primary key of this thing on the right here. It's a concatenated key of assignment ID and student ID. Those should both be yellow.
That makes sense.
Yeah,
I
think they're showing it here, student ID both being to show you that foreign key versus foreign key versus primary key. I think we get into that. We will. Yeah, we're definitely hit that one. So relationships are created between tables using the primary key field and a foreign key field. And again, the foreign key is a primary key in another table. One-to-one, you almost never do this. I was trying to think when I was prepping for all this, I was trying to think of when you would have another table that has a one-to-one relationship. Because generally speaking, if you can have one and only one something, according to the rule sets of your data, you put that as a column in your table. So if a person is allowed to have one and only one supervisor, you put the supervisor's employee ID in there. If a person is allowed to have one and only one, like in the DMV, pick a hair color, you get one. That's a column in that person table. So generally, when you're modeling relationships, it's and you see one-to-one, it's not going to be between tables generally. But the only example I could think of is you might want to design something such that some of the types of things in a table get extended by another table, like women and men in a personnel table. Women might have female might have all of the things that are unique to females as far as, pregnant or not pregnant, those sorts of things. Men you might extend those attributes for things that only apply to men. And all I can think of are medical situations, and we all know the anatomy. So there may be other business entities, like certain types of vehicles. Maybe you want to extend that table, and instead of inflicting it on every type of vehicle, if you only want to know those extra things about trucks, you would have a truck detail table that would have a one-to-one relationship, where every row in the truck detail table had a one-to-one relationship with the main vehicle table. It's kind of, that's getting out there a little bit. One to many, yeah. This is where, like I said, you're a person. You can own many cars, but each and every car has to have one owner. Say, if that's the business set, if that's the business rule, that's a one to many relation. And then many to many, when you start looking at your data and you see that there are students and there are classes, and you can have a student can be in many classes, and a class has many students in it. You just know inherently that you're going to need a table with the primary key from students and the primary key from classes together to store information about that individual student's enrollment in that particular class. And that's where you would have things like, Don in data analysis. Now you can start adding attributes to that relationship in that joining table that joins students and classes. Now, when you've got it down to a certain student and class relationship, now you can start doing, like, attendance or your final grade in that class, or maybe even, assignments and tests and those sorts of things. But that's where you start to see many to many relationship. And you virtually always will need a table to make sense out of that. And we've got examples of that. But those are the types of relationships. And when we're looking at a database diagram, you'll hear this again: one-to-one, one-to-many, many-to-many. And here we go. And this is not, these are just arrows. This is not official database design symbology. So what do we got here? One-to-one. So there's, yeah, this product in the left-hand table, uniquely identified by item and color, can only have one price. But there are many polo shirts going back the other direction. See the dotted blue line? There are many polo shirts that cost $12. So that shows you the relationship is kind of, bi-directional. And we'll see that when we get to the diagramming. And yeah, one-to-one. I'm trying to even think of what the professor was going for by this one on the right here. It's one-to-one. Each item has a particular, each item has a price, but you can have more than one item with that particular price. So it would be one-to-many backwards in that direction. These are kind of goofy examples. They'll get clearer as I start working with real data. But yeah, that's an important designation or important concept, is that these entities have relationships of one-to-one, one-to-many, or many-to-many. Now, many-to-many. See, here we go. We got an assignment and a student. See the dotted dashed gray lines here. You know you're going to need this table over here, which breaks out the assignment ID in this table can be in here many times. And this student, see the other dotted blue lines, this student can be in here many times. But each assignment and student is unique for each student. A student will only have assignment ID one time, I guess, is how you would put that. But again, it'll help a lot better to see practical examples. And then we got some. This is semi-dated, but honestly, guys, this stuff hasn't really changed. There's just really been no. There are different types of databases, and I'll go into that in the next presentation. But this is how data is put together. And so, just a quick overview of these relationships, which we will get into in even gorier detail in the next presentation. Any questions so far? Holding off till the next clear as mud. All right. Like I said, that's in the classroom for you to download. If it's got the rule set, if nothing else, it's got the actual rules of that first, second, and third normal form. Okay, a few more minutes. Let me see what's next on tap here. Okay. Yeah, next one's getting started with SQL. Ooh, it gets so dry talking. Okay. Now, if you have downloaded this PowerPoint, you can cut and paste like the IP address in there, and you'll know you've got it right. And hopefully, this will go well for everybody. But if it doesn't, let's set some time aside this afternoon, hopefully, and get it troubleshot, or you can work with your IT folks to get it troubleshot, whichever you think would be more effective. Share. Okay. Now, full disclosure, this session, these lessons for the next couple of days, that I'm using, the queries, the data, the database, was originally an Oracle database that we used last time, and we used a tool called SQL Designer that Oracle puts out. SQL Developer, SQL Designer, that Oracle uses, that is the exact same product as Workbench. Workbench is for MySQL, which is a free database. Oracle is very much a pay-to-play database. So I've had to go through and adapt both the slides and the just a tweak here or there to create the database and the queries. So if you see something that gives you pause and it mentions Oracle or something, it's probably just something I missed. So we'll be using a flavor of MySQL called MariaDB that's kind of gaining in popularity, and it's open source, so it's a whole lot cheaper than SQL Server or Oracle. Okay, this is what we're going to go over. What is SQL? Pulling data out of a single table, joining tables together. There's ways to use a query to feed parameters up to a parent query called subqueries. We'll learn a little bit about that, and then there's lots of little functions like the min of a column or the max or the average, those sorts of things. And then you can start to pull data that'll be really helpful, like in a pivot table if you're going to be doing some charting, those sorts of things. There's some other functions, group by and having, if you've used SQL before. So I would call this, what you guys are getting is definitely an introduction to SQL. There are people that have made whole careers out of this language, and it gets just mind-blowingly complex when you're pulling table data from 10, 15, 20 different tables and piecing things together using conditional logic. I mean, it can get really intense. But luckily, as an analyst, you usually don't necessarily have to write those queries. But you might. You might be expected to. It kind of all depends on where you work. All right, so why SQL? Because it is everything. You got to have data to work on, to do your job, and that data almost always comes from some sort of relational database, because this is where every functional system, your patient record system, your warehousing system, Salesforce, everything is stored basically in a relational database, or so it seems. So if there's an exception to that rule, it is an exception, not the rule. Virtually everything at some point is in the back end is in a relational database like Oracle or MySQL or Postgres or one of those flavors. And you need to be able to access databases, and a data warehouse. We talked about on the first day, it might start to be making more sense now. A data warehouse is where you would pull useful data out of your inventory system and your finance system and your human resources system and stick it in the same place so that analysts can answer questions. And that data warehouse usually gets refreshed by scripts so that it's automatic. And so that whenever you run a report in the morning, the data is fresh from the day before, kind of thing, So that's a data warehouse. It's A data warehouse is very often still an RDBMS. You can implement a data warehouse in Oracle or MySQL or SQL Server. It's there for analysis. It's not there for production. That's really the only difference. And how do we use it in analytics? That now, Dr. Downey, my colleague at UCA, put this in orange, and I left it. Most analysts have to select the appropriate data. Okay, and for that you use SQL. So that is highlighting the fact that you guys will be pulling flat files out of databases that look like these Excel spreadsheets that we're dealing with. But I would put a third bullet in there, is that you can answer questions with SQL. If people want to know what the average sales was for a given department last week, you can query that up pretty quick in SQL and answer the question without doing any extracting and transforming and sticking in another program or anything. SQL allows you to do data analysis and answer questions. And then the second one, sometimes an analyst is maintaining the database, but it's fairly rare. I would say you need to know who your DBA is, database administrator. That's the person that's responsible. That's the gatekeeper that's responsible for user permissions, the performance, the backing it up, and all that sort of thing. Our DBA is a fellow named Justin Rowan that works at Axiom, and he's created our database in the cloud in his own AWS account. Okay. I'll go 4 more minutes. If I go past 10:20, somebody stop me. Okay. These are your popular RDBMSs out there in industry. Oracle's the big dog. I started working with Oracle in 1988, and they're still number one. So they're just, and they're enormous. MySQL is what we're using, but it's really a flavor, a branch of MySQL. But they're virtually identical. There was a falling out, a spat. The guy that created MySQL didn't like the direction it was going in the open source community, so he branched the source code for MySQL into MariaDB, and they went their own way, and that's what we're using is MariaDB. Some people prefer it. It's like when a religion splits and goes 2 different directions. I don't know why do we have all these different Protestant religions, but they all trace back to you can see why they split apart. And MySQL and MariaDB are just like that. SQL Server is Microsoft's enterprise database. DB2 is still around. That's IBM's for a long time. Oracle DB2, Oracle's huge. Then you had DB2 and Informix. These companies get bought out occasionally and names changed and everything. And then Access is another one. Number 9. It's there are others, but it's a very popular single user. It's really made for doing things for one user on your own computer. And then there are other types of database management systems besides relational database management systems, and that's why you see that R in RDBMS. There are things called object-oriented databases, which I haven't seen any practical application of personally, but NoSQL databases are really coming on, and those are interesting. You can take like if you know what an XML or a JSON file is, you can upload those. You don't have to design the database at all. It just pulls that data up, and because of the nature of the data, it's queryable. I'm going to try and give you a brief tour of MongoDB before we conclude, because it's starting to be used in analytics. And NoSQL stands for not only. It doesn't mean you don't use SQL, because you can, I believe, integrate SQL for syntax in a NoSQL database. So it's not only SQL. That's what that stands for. 1 more minute, and then there's this thing you'll hear, Hadoop. Hadoop is less a database management system than a file system. It's a way to split giant problems apart and do parallel processing on gigantic data like the human genome or I don't know, millions and millions of rows. And when the processing for an analytical effort on a single machine really just won't work, they start bringing in some of these new. You'll hear about big data. That Hadoop is kind of the first big data tool. Okay, so we will come back to what we're using. MySQL, MariaDB. Let's take 10 this time, guys. Back at 10:30, and I'll finish this out, and hopefully we'll get connected this next hour. Back at 10:30. All righty then. So, Thomas, give me some feedback here. Am I crawling through this too slowly, or like just in general? Do I belabor things, or am I going at the right pace? Or
I think you're doing fine. But most of the stuff I've seen, I haven't had a ton of exposure to. So that might be why somebody who's had exposure to it may want to pick up the pace, but I'm fine.
okay, yeah, it's nature of the beast. I want to make sure I recover it. For some people, it's a review. For other people, but just generally speaking, I think I talk too much. But as Popeye says, I am what I am. All right, now we're getting to doing something here. So we'll be using, like I said, a flavor, a branch of MySQL. And if you go online, this is a huge community. I mean, all this stuff's gigantic. And we're using SQL Workbench 8.0. I think we're up to 24. Okay, so execute. Find your. It's usually under the M in your start menu. I'll give you 10, 15 seconds to start MySQL Workbench. If you get warnings, I know of a couple of them. It doesn't like the version of whatever database one. I get warnings that don't mean anything, and I just go past them. So if you see anything about versions of SQL or whatever, anybody want me to slow down? I'll count backwards from 5. Otherwise, I'm gonna press on. 3, 2, 1. All right. So you should see, once it opens, is everybody seeing something like that where it says MySQL connections? Okay. You will, to make a new connection, you click on the little plus sign. A connection is one login and one session with a particular server. You can open tabs and be connected to, a bunch of different database servers. They might all have similar databases in them. Maybe you're a consultant working for a company, or an analyst, working with multiple copies of the same database for different locations or something like that. But anyway, we're just going to be dealing with one connection. So you click on the plus sign, and everybody see a typical dialog box. Okay. So I've got the parameters in the next screen, so I may have to bounce back and forth. I forgot to pause recording again. Good grief, you guys are going to have so much dead air out there on the recordings. So in that box, first thing I know you're going to want to do is you can leave it My Connect, but or you could call it analysis _ class, something meaningful. There's a couple of different databases in there, so just name it. You could put your first name, it doesn't matter, connection name, but each of your connections will need a unique name. Yeah, leave TCP/IP alone. And the only part of the screen that I've ever had to deal with is the parameters. Under host name, on the next slide, you can cut and paste or type this in. Now, if he wanted to get fancy, Justin could have given us a URL, Uniform Resource Locator, like Don's database dot whatever, that you can type in there. So sometimes you'll be connecting to a database that actually has a meaningful name. In fact, when we were using Oracle at UCA, it actually had a typical, dbserver.uca.edu. So there's your IP address that goes in your host name block. Port 3306. It's not a TCP/IP class, so I'm not going to go into what ports are. And then your username is your first name, all lowercase, and I emailed you all your passwords. You can't really do anything to each other. I don't think any of you can have permissions to, like, delete the database or anything like that. At least hopefully you don't. So I didn't feel bad about sharing your passwords. It's literally just to connect to this class database. So I clicked on that store in Vault, so I wasn't typing in that garbage every time. If you click store in Vault, then you can cut and paste your password in. And then you should be able to click on, you don't have to, but you can type Northwoods into your default schema. We currently have 5 schemas, which are kind of sets of tables that go together, kind of like you would think of as a database. So you don't have to, but you can type in Northwoods. And then double check all of that looks good and press test connection. And you should get a dialog box saying, yeah, it looks good. You may get a version, you're connecting to something, I'm scared. Ignore that, but you should get a connection successfully completed. Anybody get anything out of the ordinary?
Yeah, mine failed.
What did it say, Andra?
Failed to connect.
Just failed to connect. Just out of curiosity, what? Take the Northwoods out of the default schema and double check, and you cut and paste your password. So you're sure it's not. I tested yours, Damon. You got connected okay, right?
It's saying
I actually wasn't download MySQL just yet. It was saying that it needs the Visual C++ thing.
Okay. When you get that, I tested your. Go ahead, Andra.
So it's saying failed to connect MySQL at the number that you put in for the host name and the port with user Andra.
Okay. Well, I'll check that out and see if I can't figure it out myself. It's not critical right this second. So anybody else?
I had trouble too. It's pretty much the same message as Andra's. So I'm trying to go back through it.
Okay, but Laura, yours went through okay. Huh. And I know Damon's did because I checked it.
There was like an error, but it said not supported, but it works just, I can pull up 2 schemas, Northwind and Northwoods.
You can't pull up schema 1, 2, and 3 underneath them?
You
don't see them?
Other schemas, no.
Yeah, that's a permissions thing.
Okay.
I'm making notes here.
I know sometimes like company firewalls won't let you connect.
That's true. It may not be allowing you to connect on that port. Andra, I'm wondering, Chaz, how are you doing?
I think I have the wrong app downloaded because it's Oracle SQL Developer instead of the Workbench.
No, you want MySQL Workbench. Whoops.
Yeah. So I'm gonna reach out to our IT guy and get it to install because it won't let me just install it without his administrative password.
Yeah. Now that we're here, no kidding, guys. Put in a ticket. Do whatever you got to do to get it installed. I apologize if I wasn't clear when the class started that we would be using this software, but there's always issues like this, and it could be a firewall port. Not every security team will let you move through the firewall like that on specific ports like that. So I'll be screen sharing and you'll be able to see what we're doing. But if you were unable to connect, whether it's, I'm getting, the mystery can't connect for like Chase and Andra.
I'll say, can you get that? It keeps crashing. I was able to connect this last time, but as soon as I did, it kicked me out. So try again.
Yeah, and I can. I mean, the only thing I can verify is your username and password, because we're coming from different environments. Are you at work, Chase?
I am, yes.
Yeah. Kind of hard to say.
Okay, I get the connection warning, connect anyway. Successfully made my SQL connection.
Okay.
I wonder if that's the problem. Well,
what are you clicking on after you successfully?
Just hit OK, and then it says my SQL workbench quit unexpectedly, and then I hit reopen, and it has me go back through the.
Oh man, and you're on a Mac, aren't you?
Mm-hmm.
Oh yikes! Yeah, if you could put in a ticket. I certainly can't help with that.
Okay.
Yikes. Okay. Well, we'll motor on.
I just sent you an email with a screenshot of the error. So I went ahead and clicked OK without testing connection, and then it added it underneath my SQL connections. But when I click on it, it gives me a server error. But then it's got like 4 notes of what to check. So maybe that'll help in some way.
Okay. But put in a ticket with your IT support. If you can't, if this didn't work for you, put in a ticket with your IT support. And I'm talking to everyone, not just Andra, because I'm not going to be able to troubleshoot the vast majority of these things. I'm going to check your usernames and passwords real quick and make sure that it's not a permissions thing that I need to talk to Justin about. But I can't troubleshoot like installation, the C++ library, those sorts of things. That's going to have to be your IT guys that have admin privileges on your workstation, and your firewall folks are going to have to open that port to that IP address. It's solvable, but you're going to need to open a ticket. I'm looking at Andres here. Yeah, I'll check your username and password, Andra, and but yeah, that means one or the other is wrong. Hang on just a sec. All right. Well, I apologize for the frustration, but I'm gonna move on and start showing you some SQL. I'm curious how many people are connected. Who can see the Northwind and Northwoods schema? I know Laura can. Did anybody else get in? All righty. Well, I'm gonna try not to let that just really sap my morale, and I'm gonna keep moving here and show you what it will look like once you get it fixed up. Yeah, it's very high level, very English looking language, and that almost reads like English. You know what I mean? They made it as intuitive as possible to tell the database to do something. We don't do, ifs and thens and loops and conditions and weirdness in SQL. Pretty much everything is a command, pretty much. Just telling the database to do something, either creating tables and those sorts of things, which I've already done, or mostly what we'll be doing is pulling data out of the database or querying the queue in structured query language, which is that select statement. So we're going to be selecting columns from tables and seeing the output. There's really, 30 to 100, depending on how, what you consider a keyword. It's not an extensive language. So we'll cover a good part of it. But there's a little bit of flavors, between MySQL and Oracle. There's slight differences, and they'll extend the language slightly. Dates can be particularly weird to work with between these. And yeah, developed by IBM in Boyce Cod in the 70s. But I want to say it became a standard language in '86, an ANSI standard language. So it's been around as a standard since, I think, '86. Yeah, the latest one, 2016, I think that's still accurate. And there are flavors of SQL, which is a little frustrating, but that is the nature of the beast. Since it's an open standard, anybody's allowed to dork with it in their own company, in their own implementation. Yeah. And data types, yes. Like if you're saying a column is a numeric, a floating point or a real, and the date data types can be goofy to work with. So I'm curious, which of these providers do you guys know that you'll be dipping into? Does anybody?
I use SQL Server pretty heavy.
Microsoft, there you go. Anybody else?
I think we also use Oracle pretty heavy also. So.
Yeah, those are the big guys in the enterprise. Okay. Oop. Okay. So there are sub uses. We won't fixate on this too much. Sub uses of SQL. SQL allows you to do pretty much everything with the database, to include adding users, giving users permission to do things, creating indexes, starting, stopping the database, all those sorts of things, not just queries. A data definition language, it lets you create, modify, and delete like tables and index and those sorts of things. But just to keep us all from doing mayhem, you guys don't have permissions to do those sort of things. But we'll briefly touch on those topics. If you are if you are charged with creating database objects, creating tables and views and your analytical database, you'll need to get used to the different commands that let you do that. Tables, views, triggers, indexes, stored procedures are a kind of like a functionality that you can call. Data manipulation language is pretty much what we'll be using it for. That lets you, it doesn't change the data in the database. It just lets you format it and limit what's coming out. Basically 3 types of data in MySQL, but I put a link down here to, I really like World Wide Web Schools. I assume that's what the 3 stands for. W3 Schools. They've got great tutorials and they summarize things really well. So I put a link down there for the MySQL data types, because there are, different types of subcategories of string variables. Definitely like a dozen different subcategories of numeric, and then date and time. And like under string data types, they'll describe like binary objects. You can store like images, text files, anything like that. Large binary objects, they'll call blobs. Binary large object. If you see that the term blob, that's what it stands for. So yeah, those are the 3 main categories. The subcategories that you'll see in our database are usually varchar, which is it automatically shrinks and grows by the amount of data that you put into it. That 4,000 may or may not be an Oracle cut and paste error. Characters fixed length. If you want something like, for example, state code, you would make that character 2, so that the database is constricted. If you tried to insert data that was too big, it would give you an error message. And then there's integer fixed point. You know, given like 2 decimal points is a fixed point, and then floating point is for really large or really tiny precision numbers. And these things will matter, just like in Python, because there are certain things you can't do with a string that you can, you know, like you can't do math on a string. So you kind of need to know what your data, the type of the data is. And yeah, these there's date and time and timestamp that we'll be using date and time in this little sample database. A timestamp generally is when you need a whole lot of precision to no kidding, you know, put down, you can, you know, down to like the microsecond. So you can do, you know, tiny fractions of a second using a timestamp. Okay, so that is an introduction to SQL, and I just want you to know why it is what it is. It's still huge, I guess, is the bottom line point. Any questions before I move on to actually pulling up MySQL? And guys, I'm really sorry that this your software is not working. Hopefully your IT guys can get that sorted out, or we'll figure out that it's just your username. I'm going to check Andra and Chase, but I would bet it's your firewall. Although the thing crashing, stopping unexpectedly, that's worrisome as well. So yeah, please open tickets. This is going to be really boring if you guys are just watching me punch these into SQL Workbench.
Don,
yes, ma'am.
just to let you know, I was able to connect IT, and I've downloaded SQL Workbench on here, MySQL Workbench, and the error I'm getting says that it failed to connect with user Chastity. So I got that information from the email that you sent yesterday.
Yes. So
it sounds like it might be an authentication issue.
It might be. It might be. I'll check those. Like I said, Damon was at the top of the list. I checked his username and password, and it let me create a connection, and I could see the schemas and everything worked fine. It could be that. It could be permissions. Like I said, I didn't check them all, so I'll get on that. Let me stop sharing that. Okay, so I'll pull up SQL Workbench. And share that screen. We'll get it figured out. We can always go do some Python. Feel like I'm falling behind in the Python department. Okay, so here's your and I said, yeah, don't tell me anymore when it came to that compatibility message or version. Laura, what was it that it said? You saw it.
Yeah, it said not supported.
Yeah, which isn't a fatal error. So, okay. So once you get into SQL Workbench, it's kind of an integrated development environment. You'll see once you get into programming, I told you, Jupyter Notebook's not the only way to do Python programming. There's also these things called integrated development environments. And the main thing is that they work well with the language. They let you manage the data that you're working with, whether it's Python or Java or here we're working with databases. There's almost always a window for your output. Any warning messages will come up, those sorts of things. Over here in this panel, you see schemas. A schema is something underneath a database. Like this thing is a MySQL database server that can tolerate, hundreds of users working on, different projects. You could have your finance guys, you could have your analyst area, you could have multiple schemas. Those are where you would group together tables that have relationships. You know what I mean? And we'll be working mostly in Northwoods, which is a simulated small college that we use for a lot of these queries. Inside of Northwoods, you see you click on this little arrow here, it'll drop down the tables. We don't have any views. Views are kind of like a table that you create in order to neck things down and kind of constrain things. We'll work on that a little bit before we're done with the course. But we got 1, 2, 3, 4, 5, 6, 7 tables. So fairly small. And again, it's just a sample for us to work on some queries. So that's where you see a description of your database. I kind of wanted to show you a little bit of SQL before we get going too much into. I still need to go back and cover the diagramming, the entity relationship diagram. So let me put away getting started with SQL and bring up single table queries that gets into the language a little bit. So what I'm pulling up now is that single table queries PowerPoint that I uploaded, but there's also, like I said, that .sql file that has all of these queries in it, so that you can just cut and paste them. Once you get SQL Workbench working, you can cut and paste out of that labs document, so that you're not constantly having a fat finger. Okay, so now we'll launch into the actual syntax of language. I'm sorry, guys. I'm trying to get enough screen real estate to do both of this. Okay, if I stop share and share my entire screen. I hope this isn't too small. Holler, let me know here just a sec. Share screen. Okay, so I'll make the PowerPoint a little bigger while I'm talking about the PowerPoint. Okay, so the basis of these SQL commands, and again, they're commands. They're not really programming, not really if then else looping around doing all. It's really just a command that executes. But oh my goodness, these commands can be incredibly powerful when it comes to telling the database what you're looking for. So here's the basic syntax of a select statement. Now, of course, my buddy Jim had field name, and those are columns, right? So you would select like, select last name, comma, first name from the name of the table, people table, personnel table, student table. You don't have to say the word table. It's just the name. And then you can start to limit what data comes out based on what's called a where clause. So you could say select last name, comma, first name from personnel where department equals accounting. And it would pull everybody in the last name and first name of everybody in the accounting department. So the syntax is pretty intuitive for just for readability. Generally speaking, we put the keywords in all capital letters. This is just you'll see out there among SQL programmers, and it's good form to put the select, the from, the where, and then there's a couple other clauses you can add. They go on their own line, just for readability's sake. That's just the convention of that SQL has developed over the years. So that's the basic syntax. So like, for example, and it just so happens these are cut and pastable. Oh, and every statement ends with a semicolon, because you can put these in a file and execute SQL statements independently. And in that script, each individual SQL statement needs to have a semicolon at the end. So I'm going to just select all of that and cut and paste it, and then go over here to SQL Workbench. And I had been goofing with it. I don't really need that window. Can I? SQL Additions. If I knew better, I'd get rid of it. But over here in Workbench, I'm in a kind of a working window where you can type in queries. You can do more than one thing here, and you can execute multiple things inside of one of these windows. Or I kind of like keeping things simple. I work, one thing at a time. So I was goofing with that before, but I cut and paste that SQL command in there, and you see the power of an IDE is that it starts to recognize the language and tell you when you're doing something wrong. And it also formats the command kind of automatically, kind of like we saw in Jupyter Notebook with Python. IDEs, generally speaking, are even more powerful when it comes to auto formatting and giving you some error checking before you even hit execute. So here's a select statement. We have a student table over here in our database, right? So if I this lightning bolt, when you're in there, executes everything in the script window, kind of like when you're in a cell in Jupyter Notebook and you hit the play button, and then you get your output down here. So you see it uses the column name from the database, which may or may not be super pretty, and we'll talk about how you can change that. And it displays them in that order across, from left to right. So there's our 4 columns that we selected, and there's your output. So that's boom, we just executed a query. Okay. Going back. Now, sometimes you can have 1,000 people but they're all in 6 different departments. You don't necessarily want to see and go through and look and try and figure out what the legal department names are, right? So it's kind of like in Excel, you would sort and filter. This one, there's a select distinct. You put distinct in front of the column name. Guys, I feel terrible. I was really hoping you would be doing this, following along with me. So we select distinct F rank from faculty. I'll show you if you leave that off and execute it, we get a row. We get the faculty rank for every row. So we've got 2 full professors, 2 associates, 1 assistant, and 1 instructor. But if you use the distinct, yeah, here's another cool thing. It will guess, just like in Notebook, it'll guess what you're trying to type, and you can double click on it, or I believe hit enter, and it'll pull it up. So select distinct. What we were dealing with, F underscore, and then it guesses what column you're trying to use. So if we arrow down to F rank and hit enter, it automatically populates that. So you'll see this when you get it up and running. So then we run to select distinct, and instead of getting 8 rows returned, we get 5, which is just the unique values. So that's what distinct does for you.
Don, is there a way to look at these tables like before you run a query so you know what columns?
Yes, there are.
That you're able to query?
Sure enough, yeah. If you're in a graphic user interface like Workbench or like Access, working on a database, generally speaking, you can just go over here and click on these arrows and expand this out, and you'll start to get the names of the columns at least. But there's a SQL command called describe. Hopefully you guys can see my screen. If you type in describe, and what were we dealing with, faculty? And I know there's a hotkey. I just don't know what it is offhand for doing the lightning. The describe command will give you the column names, otherwise known as a field, the data type, and then any constraints that are placed against it. You can, when you create a database, you can tell it that a column is not null. That error, if anybody tries to stick a row in here and stick a null value in this column, this has to be populated. And then this key column here tells you that F underscore ID is the primary key. But I believe these are foreign keys. I'm not sure what the MUL is. I'd have to look that up. But that tells you that's a primary key. So that's how you describe a table and get it back as a, as SQL output. Or you can go over here. I'm curious if I'd like double click on course ID. Yeah, down in this lower left box, you get more information about that actual field, like if it's a key and what its data type is. Good question, Laura. Thanks for slowing me down. Okay, so that was select distinct. Gets you not just every row in the database, but the unique values in a given column. And then we go back to the PowerPoint. And yeah, a lot of times you're going to want to limit the rows that are coming back from a query, and that's where you use different statements and operators and functions in your where clause. That you always, that's what you call the where thing. It's a where clause. I don't know why. That's just what they decided to call it with the language. So here's some queries that show limiting the data that's coming back using a where clause. So I'll cut and paste that first one and go back over to SQL Workbench. So we're selecting the first name, middle initial, last name, and rank from faculty, but we only want faculty are ranked by like associate professor, assistant professor, full professor, and then they can be like department chairs and that sort of thing. So there's, man, it's a big deal if you're a if you work at a college, the actual rank of the professors. So this is only going to pull back, and F rank is a var char, so it's a string that you put in quotes. MySQL hates single quotes. Oracle loves single quotes. So I had to go through everything I'm using and change single quotes to double quotes. So if it errors, it's what it is. It's a cut and paste error. So when we hit that, boom, we'll get just the associate professors.
Is it case sensitive? Like, does it have to match exactly if you use that where clause?
I got a slide on that. I don't think so. I think it'll match, but let's try it while we're here. What the heck? Just for fun. I think I think it'll still match. Let's see here. Yeah, it's not case sensitive inside of that string. I think you can make it. I think there's a clause or an operator that you can put in the where clause that forces it to match case. You know, kind of like you do in Excel. It'll find anything unless you say match case in the search and replace window. Good question. Numbers are a little more precise, a little more literal. So that's how that one worked. All right. Yeah. Oh, yeah. And you can have, I don't know how many conditions, but definitely more than one. This next query uses the and operator. So yeah, which we used in Python. So you can use and or within these. You just gotta watch your logic. So this one will pick the room number from the location table, where the building code equals bus, and then we'll go here and expand out the location table columns. So you've got a location ID, a building code, room numbers, and the capacity of that room. And capacity is a numeric field, an integer field. So that's why you don't need quotes around capacity. And we'll click on that one. And unknown column, room in field list. Select room. Let me try that again. Oh, I must have just had something highlighted or something. Oh, yeah. This lightning bolt, guys. See the little dialog box, the little pop-up that comes up. Execute the selected portion or the whole thing if nothing is selected. I think I had a little bit of I think I had that top line selected. So we select that and we get room number 105 and 211 because their code, but we did not select. You don't have to select the column to have it be in the where clause. You can just select one column and then limit it by a bunch of other columns. So that's a good example of that one there. Okay. 11:14. Anybody want to slow me down? Keep going. Keep going. And again, sometimes you want to you don't want to pull data that is null, or sometimes you want to go looking for null records. So you don't use equals. You say is. But I think we're going to do an experiment on that. So select. Oh, and here's another good. All columns in a table is splat or star asterisk. Select star from enrollment means select every table. It's kind of like a wild card. So we've got this enrollment table, and it has three columns. This is that many-to-many table we were talking about before. It's got a student ID, a course section ID, and then the grade that the student got in that section of the course. So we want to select star from enrollment, every column where the grade is null, and this would be like not graded, Okay. So we get 8 rows back from that. Let's do is not null and run that. We get 12 rows back. There you go. So that shows you the difference between is null and is not null on a given field. It only operates, we're selecting all the fields, all the columns, but we're only limiting it based on grade being not null, or which by these examples. So is not equals, but we're going to do an equal sign and see what kind of error message we get. Where grade equals null. I'm surprised. SQL Workbench will put a squiggly red line, kind of like a Microsoft Word misspelled word. It'll put a squiggly line under something it doesn't like, and you click on it and it'll tell you. I was expecting something different here. So select star where grade equals null. 0 rows returned. Well, there you go. So equaling null is not the same as the binary operator is not null. And I don't know why that is, but it is. I remember working with that back in the day. Okay.
So it doesn't have anything to do with it being an int versus a varchar?
I don't think so, because I think it'll do that for any kind of data type. We can check that, Thomas. So what we were trying to do, well, no, because that's all columns. No, we're grade. We're grade equals null, and grade is what kind of? Grade is a single character, so it's a char variable. Let's do a number variable. I'm trying to remember, but location had an integer. Capacity, yeah. So let's select star from location where capacity, and see what happens when you call a numeric field equals null. Yeah, no specific red lines yet. Let's see. Bam, nothing. So equals null, it doesn't make sense. And I without doing some Googling, I wouldn't be able to explain it, but I do know that in SQL, regardless of the data type, when you want to check for null or not a null, anything but a null, you use the is, you don't use equals. And that is the way it is. Oh yeah, you provide a list of possible values. So there's the in operator of a where clause. So we'll run that and we'll see where we're pulling. So these are all A's and B's. So let's pull everybody that I think it's not in. Yeah, not in, which pulls the opposite. Okay. So those are real similarly constructed to, like to the way we do logic in Python, only it's in these single line queries. Yeah, let me pull this one, make it a little bit bigger. Like is looking like a character string, matching part of a character string. We'll give this one a shot. There's an example in the next. And then we talk about wildcards. If you wanted to perhaps you want all students whose names start with G, the character string would be G %. So it's G and then anything, G anything. And these wildcards are on the next slide. Percentage is anything. A wildcard is a given character. And sometimes when you're querying data, you'll have strictly formatted data and you want to pull, it could be like, customer account type or something like that, where there's some intelligence in the way the data is formatted. You might want any first two characters and then everything else, kind of, wildcard, or the opposite. So we got some examples here. 11:20. Now we need to take a break. Take a break, and then we'll finish this one out. And then, man, I am just bummed that you guys are having technical difficulties with SQL Workbench. I really wanted this to be more of a you guys cutting and pasting and hands-on kind of thing. I'm bummed. All right, let's take 9 back at 11:30. Alrighty, I forgot to hit pause again. I guess better to forget to hit pause than to forget to hit record. Okay, so I checked Andra and Chase's credentials, and on my computer it lets me write in. So I'm thinking this is a firewall issue. If you're Chase, you are at work, you're behind your company firewall.
I'm on just my personal computer, so I won't be able to issue a ticket or anything. I don't imagine.
Yeah, you can.
I'm gonna try. I think it's my operating system. I'm gonna make sure. I think if I update it, that might solve the issue. But
oh, that's right. Yours is crashing. Yeah, that's different.
I'm on the most recent OS on Mac, and it worked on mine.
Yeah, and that link that he sent us, it said it requires Big Sur, and I don't have that yet. So I'm hoping that'll fix it. But
so you guys are talking that Apple talk. I don't understand.
You might be able to go to an older download, like an older version of that. Okay. I think Oracle keeps all of their like old versions.
Oh, like downloading SQL Workbench 7 or something like that, Mike?
Yeah.
Okay. Yeah, I'll let you sort that out. That's your computer. I don't want to break anything. But Andra, are you at work behind your firewall? Because your username and password worked for me.
Are you talking to me?
Andra?
Yeah. My audio broke up, sorry.
Are you at work?
I am not, but I am VPN and
can you not VPN in and check it again? Can you disable your VPN and just use
work if I'm not linked into the work server?
I'm sorry?
So I have a VPN to log in to actually access my work stuff. And so I'm trying to see if I can do it without having logged into that. So it's just like a regular computer with internet access.
Yeah. Did you download and install Workbench on your actual workstation or on your a virtual workstation that you're VPNing into?
It's on my workstation. The VPN is only to have permission to access certain websites.
That's probably what it's doing. It's taking control of your network connection. So if you can disable that and try it again, it may let you in. But again, this is something everybody's got a different environment, and I am not even a tech support guy for your company. But if you'd let them know what you're required to do, and you might talk to Scott or Jeremy. They were using SQL Designer or SQL Developer, but they might have ran into a similar issue and know what to do about it.
Well, it worked. I'm in.
There you go. I fixed it.
So Chaz, disconnect your VPN.
Yep, it seems like that did it.
There you go. Cool.
It's just me now. All right.
Well, it's not just you. Aaron's awful quiet.
Yeah, mine's asking that I update my OS system.
Okay.
Yeah, that's all right.
Yeah, you Waco folks might be in similar situations.
Yeah, I gotta get the IT guys to add it to mine.
Yeah, and Thomas, you're still sitting on that C++ library thing. I don't remember what I had to do, and some of you got needed admin privileges. So yeah, if you're still unable to connect, please get a ticket going with IT and let them know that it's it's a priority for me. Your employer has devoted 20% of your time to this course, so they're going to want to get a return on their investment. And to me, monkeying with this stuff hands-on is way better than listening to some guy talk. So please, for my sanity, if not for yours, because this is bumming me out if you can't play along. Cool. Thanks, Chase. All right. So back to our saga. Connect to my database again. entire screen, share. Okay, so these are, yeah, single table queries, not doing anything too terribly complex yet. So moving on. Yeah, we had our wildcard description. So %sign 2006 is anything preceding 2006. Any string of characters that ends literally in the numbers 2006. And I think we're going to have these that I can cut and paste real nice. Yeah. And proves that that works. And then the other one. Yeah, it can be before or after, and I want to say before and after, but we'll try that real quick. It is literally a wild card. So we'll type that one in to check trailing characters, anything fall. And so you see we get fall 2005 and fall 2006. But let's try an experiment. Scientific experiments where anything surrounding 00 on or 00 on either side. I'm curious if I'm gonna blow it up or no, it worked. Which is probably everything. So let's neck that down a little bit. How about MM would be less? Hopefully we'll only be getting where the term description is summer. Bam. There you go. So that's your % wildcard. And then like I said, does capitalizing matter? Yeah, I knew I had a slide on this. Was that Laura who asked about case sensitivity in the string literal? Who asked about that earlier?
Yeah, that was me.
Yeah. Does case matter? Apparently not. Let's test that theory again. See the squiggly line? Is that too small for y'all to see? Unfinished double quote string literal. It doesn't like all these spaces before the semicolon, I think. No, that's the wrong character. That is not a double quote. That's whatever the other thing is. Apostrophe. Hang on. Double quote. Double quote.
I know when you're cutting and pasting out of a command window into SQL, it won't like the double quotes. It doesn't read them the same way.
Ah,
So
there
you
you
have
go.
you have to retype them.
There you go. So yeah. Programmer beware. So here we go. We'll run that fall 2005, 2006. And if we put a lowercase f was the question, run that, it still comes in. So case does not matter. But I want to say, like I said, it'll come up again. There's a way to force that criteria of case sensitivity. So we've already done this. Yeah, pulls system with % before and after. We'll pull anything that says systems inside of it. We don't need to run that. Yeah, here's a good one. Using the underscore to represent a single character, which is, did I jump over it? The rest of my query's gone. All values for S class think I deleted my hang on, guys. Okay, we're S class. Is S class in term? No. Is it in section? Enrollment. Sorry, guys. I'm trying to find that. I'm tightroping without a net here. I'm not really sure where I was supposed to demonstrate that one. It's kind of bugging me, but I'll get over it. Yeah, so that would retrieve 1R or ZR or any character and R there. I'm just trying to figure out where the S class field is or column is, and it's escaping me. Okay, here's an interesting one. Oh, combining it. So there's 2 underscores, I believe. There, yeah, 2 underscores. So this is going to find anything 1 blank blank under call ID. So we'll run that, see what we get. Anything 1 blank blank. Yeah, 101 and 155 at the end there. So you can combine wildcard. In the like, and you don't say equal, you say like. And then we can use for mathematical fields, we can use the expected mathematical operators. Just like you would think. There's all the rich folks. And even though salary is a floating point with a decimal point, you don't need to put that in the criteria. It'll take an integer. Data type in the query. And another one. And you guys, all these queries are in your that labs document. I'm not going to go all the way to 1230. I'm dry as a bone already. So there's 2 columns based on the criteria less than or equal to, just like Excel, just like Python, just like you'd think. Mathematical operators, but you use the actual mathematical operator, not the like operator. And then data, generally speaking, data in a table is not sorted. You can't count on it coming out in any particular order. Sometimes the database, when it's deciding where to store things, will change the number. Generally speaking, though, in my observation, as you add rows, if you're using a system generated primary key, it'll be in order by when they were inserted. Just because of the way it by default it tends to create an index on that primary key. If that primary key system generated, it's generating it automatically each time you add a row to the database. But a lot of times when you're kicking data out that you're going to work with in something like Excel, you might as well put it out in a particular order. And that's where we have another clause, like the where clause. You have your order by clause, where you're selecting your fields, which you can have an unlimited number of fields from table name. And again, we're only selecting from one table now, but that's not a limitation. We'll get into multi-table. where, and then we've seen some search conditions, you know, mathematical operators, like operators, is null, not null. There's lots of things you can put in a where clause. But then you want to order by a particular field. And it's got to be, I want to say, let me read my screen before I start talking. It's got to be one of the things you're selecting. You can't select last name, first name, and hair color order by age. I think it's got to be one of the select statements. It's got to be one of the fields that's in the output. Yeah, by default, numbers go from low to high, characters go alphabetically, dates when you order them are old to new, but you can add a, that's, so by default it's kind of ascending, but you can tell it descending. DESC is short for descending. So you can tell it to sort the output in reverse order. And here are some examples. And order by capacity. And then if we put the order by capacity descending, it goes instead of 55 and then 150, it'll be the opposite. 150 and 55. So it's an example how that works. Yep, so I got those two done. There are, okay, so back in the day, back in the olden days, SQL was a reporting. You could write queries, and you see how we're getting kind of columns and rows and stuff out there. Well, when you're at a good old DOS prompt, you know, a command prompt or a Unix prompt, you know, like in a character-based operating system environment, not a GUI like we are here. The output from a SQL statement, you know, it has column headers and it has rows, and there are lots of formatting commands to make things look better. You could break, like, do a little section break every 10 records so it's more readable. There are ways to rename the columns, which is handy if you're going to spit this out to Excel and you want something meaningful. You might as well go ahead and put what we call an alias on that column heading while you're doing your data query. So there's a lot of things that SQL can do, and we'll go over a couple here. So this is a particularly good one to change what's in the database, especially like if you're doing calculations and you want to name that, column that's coming out something that's more meaningful. You can do an alias here, and we'll got an example. And why this is in bold and in a totally different font, I do not know. But this code renames BLDG underscore code to building. So if you're, by chance, if you're doing these queries and maybe presenting them to management, you want it to be a little less nerdy looking like these column names. So you can do an alias. So we'll cut and paste that one into Workbench. And you'll see in your output now, instead of using BLDG underscore code, it's calling it building. And that will translate. I'm sharing my whole screen, right? Yeah, we'll go ahead and I'll export that to a CSV file on my desktop called done.csv. Save. And I'm going to go to my desktop, minimize everything, and then I should have don.csv, which would look like an Excel file. There it is. And if you double click, I have CSVs associated with Excel on my computer. I think it does that by default. So I just did a query. I renamed my column, I aliased my columns, and I saved it as a CSV so that I can now go in here and do some data analysis in Excel. So that I wanted to show you that kind of soup to nuts. It's super quick to save the results of your query out to a CSV. We'll do that again. So I just wanted to show you real quickly. Don't save changes. Don't stop believing. So there's my, okay. And then Jim, my buddy, Dr. Jim Downey, put a couple of exercise queries for you to do there. You can kind of sort of, think about how you might make up your own. I did want to real quickly show you, it's up there in the classroom, the entity relationship diagram for this database that we're using, this Northwoods database. It's very simple, but I wanted to kind of go over that real quick so that you get that content. So let me close. Oh, before I move on at all, I'm sorry. Any questions about any of these clauses? The best thing is to use them. So I've got a homework file. I won't assign that today, but it's very flexible. You can pull as many columns as you want from a table, and then limit which rows come out. So you can limit the columns in the select statement, right? And then you can limit the rows in the where clause so that you only get what you're looking for. And then you can sort it by, and actually you can do more than one. You can order by capacity, and then within capacity, you can order by something else. You could say comma, comma room. Well, I'll do that out in Workbench. So right now, what are we doing? We're sorting by capacity, and by default, sheer luck, the room number is coming out as 211. So we're not sorting by room number, obviously, because it defaults to. So let's change that to, and remember, you use the column name. I think it'll choke if you use the alias up there. Order by capacity and then room. So let's see if room number changes sorting within that capacity. Now, this isn't a good example because there's only one type of capacity. No, it's not, because there's only one. It's sorting room number within capacity. There's only one capacity. So let me think of another that can do an order by. What's our biggest table? Like everything from faculty. Okay. Select star from faculty. Since we're selecting everything, we can do an order by. So let's do order by loc ID. See what happens. We hit the lightning bolt. Okay, so we're now ordering by loc ID, which is 9, and then there's a couple of 10s, and there's a couple of 11s, a 12, and 2 13s. And within loc ID 10, see how we're sorting descending, which is against the default, by salary. So if I change that, let's see if Blanchard and Jane Boston's salary or order doesn't change in the table because their salary is different. But within LocID, now it should sort. Let's see who else violates the default. Yeah, Baines and Brown are violating that. So we should see a couple of changes here, right? Execute. Now everything is still in order by LocID, but now Boston came first and Blanchard. So you can do multiple sort levels. You know what I mean? And we'll there's other stuff you can group things and do subtotals by magic. It's cool stuff. So I am going to stop. We're at a good place at the end of this presentation. And I'm about out of spit. I am about dry. So how we doing there, guys? Was that, I mean, now that we've figured out some of the connection errors, questions, concerns?
I have a question about the aliases. So
Sure.
like in some cases, some of those table field names are like not really identifiable.
Mhm.
So like once you create an alias, can you then like use that? So
In your query?
in your query, yeah.
Yeah,
like,
you can.
order.
I think that's actually it's not an alias because an alias is for display, I believe. I think what you're looking for is called an as modifier. Let's try that. Let's try that real quick. So what have we got for things in faculty here? Select or ID. Just an example. I think you always want that from on the next line for good form. Let me try this, Laura, and yeah. So I created an alias there, but I think now, as opposed to the other one, which was just for display, I could say select that stuff from faculty where first name what do we do? What do we say is like, and then the like operator was anybody. We got a couple of J's there, so let's do J %. And a close paren. Doing all that from memory now, not a script. So I broke something. It doesn't like. Select is not valid at this position for this server version, expecting 4 lock label. Yeah, I did something wrong. Let's do equal. Let's do an equal sign, and maybe that'll fix it. Where first
Is
name.
it because you're doing an order by?
It's the order by that's blowing them because I didn't select them. Thank you, guys. Where first name equals Kim. Unknown column first underscore name. You know, there's a way to do it, Laura. There is, and there's a way to it might, the as clause might be renaming tables, because when you're doing a complex query, a lot of times instead of typing faculty dot column name, when you're doing all this multiple stuff, you're going to want to refer to faculty as the A table, and then some tables as the B table, and then you use A dot column, B dot column, and you see a lot of that. But I want to say, I certainly thought you could do that with aliasing columns. I'll look it up and I'll let you know Thursday morning. Good question. There was something else. Oh, Thomas, if you want to work on your states project, can you send me the data where it's the state, and then but include that helmet law category in there, and then the number of fatal accidents, number of not fatal accidents.
Okay.
I don't think I have the helmet law, because to me the question is, when given the freedom to not wear a helmet, what's the effect on motorcycle fatalities? Just for everybody's catch everybody up on the conversation, Thomas is doing a really cool project on looking at motorcycle helmet laws and do they really make an effect? And in states that have a helmet law, they got way more fatalities with helmets than without. But duh, everybody's wearing a helmet. So you every once in a while you get the goober that's trying to get on YouTube not wearing a helmet, killing himself. But by far, it's the people that are whatever, speeding or getting smashed by a semi, but they're wearing a helmet, because if they don't, they'll get pulled over. So that kind of skews the data. So I wanted to look at the states that have really permissive or no helmet law, and then look at, no kidding, given the freedom, what's the percentage. But there's probably even some more data in there, Thomas. That's a great mental exercise, though. So
yeah,
yeah,
there was a lot.
Yeah. There's a lot to it. Okay, guys. If you haven't, you've seen now what 4 or 5 folks go. I'm not looking for anything complicated on the states project. So if you haven't turned it in, please do. I'd like to do a half an hour of those until we're done. So hopefully in the next day or two, we'll be all done with that states project. If you need help, email me, please, and I'll do what I can to help you out. On the workbench, please submit a ticket today so they can get that sorted out for you. And as always, email me with anything. Oh, and Chaz, I wanted to goop with your data a little bit and then send it to Whitney if I can't figure it out. But I think I might be able to figure out what I'm thinking about doing.
Okay, sounds good.
Cool. Anybody else with questions or concerns? So we'll hop on and do some cooler stuff with SQL on Thursday, and maybe knock out a Python notebook or two, which I know when you're trying to learn the syntax of one language to the other. So hopefully Python as a coding language is going to be different enough. And hey, making mistakes is the best way to learn, and and figuring out how to fix it. So, okay, guys, cool. Good session. Email me if you need me, and otherwise I'll see you Thursday morning at 8:30.
Thank you. See you.
Thanks, Don.
Bye.